this online video series. This is Integrated Math 3, Unit 2, Lesson 3 video. And in this video, we're going to look at graphing polynomials from standard form by factoring. But again, before we do that, let's go ahead and hop into our warm-up for today. So if you would take a moment and try these 5 problems. Okay, so 9% of 11. 9 times 11 is 99. Obviously 99 is going to be way too much. So move the decimal in one place. 9.9 still doesn't make a whole lot of sense though, does it? That's way too much. That'd be actually 90%. So let's move the decimal one more place, 0.99. That makes a whole lot more sense there. Number 2, simplify square root of 72. We can rewrite that. 72 as 36 times 2, leaving us with, let's see, square root of 36 is 6. The square root of 2, this 2 is not a perfect square, as we talked about last video. So that's going to stay inside the radical because we can't evaluate that part of the radical. Number 3, factor x squared minus 81, as we talked about in our last video. This is a difference of 2 squares. So that's going to be x plus 9 times x minus 9. All right, number 4. Again, going back to our previous video, which is greater, 57 times 67, or 51 times 67, or 57 times 61. Both of those are equidistant from one particular number, and that number being 59. So this one is 8 below 59. This one's 8 above 59. This one is 2 below 59 and 2 above 59. So as we said in our last video, the closer you are to making a square, the greater the area will be. So in this particular situation, this is going to be the greater one. Number 5, completely factor this here. This is a cubic with 4 terms. So really our only option here is to factor by grouping. If we group the first 2 terms and the last 2 terms, we can think about how to do that. So if we factor out x squared from the first 2 terms, that leaves us with x plus 6. If we factor out a negative 9 from the last 2 terms, that's going to leave us also with x plus 6, which is nice. That's how we know we're kind of on the right track here. Then from there, we can factor out an x plus 6 from the entire expression, leaving us with x squared minus 9, which then the x squared minus 9 can factor even further. So that's going to factor in x plus 3, x minus 3. So if you've seen the last 2 videos, if you've seen the video on factoring by grouping, and you've seen the video on difference of 2 squares, this combines both of those. So we started out by factoring by grouping, which left us here, and then we said, okay, now we know how to do difference of 2 squares, we can actually take that one step further. So now we've got 3 different factors, and we can actually start thinking about how to graph this cubic, because now we know it has x-intercepts of 3, negative 3, and negative 6. So we can start to think about what that graph looks like. And that is precisely our goal for today, is to use multiple factoring methods to graph polynomials starting in standard form. So while they're starting in standard form, we're going to use factoring techniques to write them in factored form, so then we can graph them. But before we get into that, let's go ahead and go back and review how we graph something from factored form first, and then we'll talk about how to get to factored form here in a minute. So this is a factored form polynomial. Let's see, we have 1 factor here, we have 2 here, so that makes 3 total, and then 4. So this is what we call a quartic polynomial, degree 4. It has zeros of negative 2, because that's what makes this parenthesis 0, positive 1, because that's what makes this parenthesis 0, and negative 4, because that's what makes that parenthesis 0. Keep in mind though that this 1 has a multiplicity of 2, because there's 2 factors of x minus 1. And all that means is that at that x-intercept, it's going to bounce off the x-axis at that point. So, let's see, what else can we figure out? We know the x-intercepts are negative 2, which is here, positive 1, and negative 4. We can know the y-intercept. Again, the y-intercept is the y value whenever x is 0. So if we substitute 0 into this for the x values, let's see what we get. If we put 0 in here, we're going to get 2 times a negative is a negative 2. So we're at negative 2 so far. Put 0 into here, we're going to get negative 1 squared is 1. So negative 2 times 1 is just negative 2. Times, put 0 in here, you get 4. So altogether, we're going to get negative 8. So our y-intercept is 0, negative 8. So right 7, 8 right here. So we can kind of start to see this thing being taking shape here, but we also need to know what the end behavior is, because that's going to help us kind of track, where it starts and where it ends. So the end behavior of this one, so we have a degree 4. So from our last unit, we talked about even degrees act a particular way. So quadratics, quartics, degree 6, degree 8, all act in a similar fashion in terms of the end behavior. But there's two different options. One is if it's a positive leading coefficient, and one if it's a negative leading coefficient. Here it's a negative. So what that means is it's going to end up going down to the left and down to the right, just like negative x squared would look. Right? Remember the concave down, negative x squared? A negative quartic will still end up going down and down. Now there's going to be a lot of stuff that happens in between that, but it ends up going down to the left and down to the right. That's what we mean by end behavior. What ends up happening on the far ends of the graph on both sides. Okay, so I'm going to try and connect this as best as I can. Keep in mind we're going to have a bounce right here. It's going to bounce off the x-axis right here. All right, so it's going to go through at negative 4. Actually, I need to move this over one, don't I? Negative 4. It's going to go through there. We don't know how high it goes in between the two, but we just know that it goes up. Did you have something else? Oh, okay. So yeah, it's going to go up, and it's going to, we don't know, again, we're just going to have to guess kind of how high it goes. It's going to come back down, though. We know it's going to come back down through this point, and then the next spot it has to go through is this y-intercept. Again, we don't know how exactly this graph looks, but it's going to go down, and it's going to go at some point, somehow, it's going to go through this y-intercept, and then it's going to go up to this point here. Now, if you forget that that's a double root and a multiplicity of 2, if you forget that, and you're like, oh, I'm just going to go through this point as well, well, that doesn't match up with what we know is going to end up happening. We know it's going to end up going down to the right. So that can help us, fix our errors here. So if we go up, we know it's going to bounce because it has a multiplicity of 2, and it's going to come back down and keep going down, down forever in that direction. So this is what a quartic function can look like. And so just a reminder from our last unit how to take factored form and plot key characteristics from that. Okay? But that's not our goal for today. Our goal for today is start with standard form and be able to plot something like this. So let's get into an example of that. So this is a cubic function in standard form. And we can tell two things just by looking at standard form. We can tell the y-intercept, and we can tell the concavity. The concavity is the leading term here. It's positive. So, not the concavity, the end behavior. We can tell by looking at that. So the degree is 3. Degree is 3, which the significance of that is it's odd. All the odd degrees act the same way in terms of end behavior. And because it's positive, we know it's going to be down to the left and up to the right, like positive y equals x. Y equals x looks like this, doesn't it? It's down to the left, up to the right. Positive x cubed, looks something like this. It's down to the left, up to the right. So it all looks the same in terms of the end behavior. So we know the y-intercept is negative 4 right here. That's all we can tell by looking at standard form. Again, the y-intercept is negative 4 because it's the y value when x is 0. So if x is 0 here, that becomes 0. If this is 0 here, that becomes 0 and 0. And so those terms don't matter anymore. All that matters is that y-intercept at the end, the very end value, the constant. It's actually the d value. This is a here, b is there, c is there, and then this is actually d in this case. It's c with a quadratic, but because we have one extra term, it actually makes it d. So anyways, let's go ahead and factor this and see what more information we can find. So if we factor this one, it's going to be factored by grouping. So we're going to factor out an x squared from the first term, two terms, leaves us with x plus 1. A negative 4 from the last two terms, leaving us with x plus 1. Therefore, we can factor out the x plus 1, as we talked about 2 videos ago. And that's going to leave us with x squared minus 4, which actually factors further to x plus 1 times, what does this factor to? Yeah, x minus 2, x plus 2. So here is our function in factored form. So we can tell a lot more now by looking at factored form. We can actually tell all the x-intercepts now by looking at factored form. So we're going to have an x-intercept of -1, 2, and -2. So let's plot those. -2, -1, and +2. Okay, so those are our x-intercepts. So now we can kind of put all the pieces of the puzzle together. We're going to start at the bottom left here, and it's going to come up, because we knew that was the end behavior. It's going to come up through this x-intercept of -2, and at some point it's going to come back down. And it may be where it like goes way up here, and then we don't know. We just know that it goes back down through this point of -1, and then at some point it's going to go through. It's going to go through this y-intercept and back up through there, through our last x-intercept of. This should be moved over one, shouldn't it? Through our last x-intercept here, it's going to go up through there and finish going up to the right. So we can draw a pretty good sketch of this just by taking what we know from standard form and what we know from factored form. So that's kind of the idea here, is that we can use these factoring techniques that we've learned to help us find out more about the graph of these. So in this next one, we're going to factor this one together, and then I'm going to give you a chance to try to finish it off with the graphing part. So this one, we actually haven't really talked about a version of this before, but it's a quadratic setup. Let me rewrite this in a way to help you understand what I mean by that. So this first term, we can actually rewrite as x squared minus 13 times x squared minus 36. So you can think about this just like a normal quadratic, right? The leading term or leading coefficient is 1. So really, we just need to think about what multiplies to give us this, adds to give us that. But the only difference here is in our parentheses, we want to get x to the 4th out. So what are we going to put here and here? X squared, right? Everywhere there's normally an x, there's an x squared now. So we're just going to put x squared here and here, and it acts just like a quadratic in terms of its factoring. So x squared here and here. All right? Well, what multiplies to give us -36? That adds to give us -13. Nine and 4. Both of them have to be what? This should be a positive 36. Let me make that change. Yes, thank you. Yeah, thank you. So, so then what does it end up being? Yeah, -9 and -4. Okay, so what's nice about both of these? Yeah, they're both difference of two squares. So this factors into x plus 3, x minus 3, times x plus 2, x minus 2. Okay, so let me give you a chance to try and graph this one on your own. Okay, so in this equation here, or this function here, we have 4 different zeros. We have -3, +3, -2, and 2. So let's go ahead and plot those. -3, -2, +2, and +3. Now within behavior, we know it's a positive even degree, so it's going to be going up to the left and up to the right. We know that much. The y-intercept is actually going to be 36. I'm not going to graph that. I'm just going to kind of go up and break the graph at one point. But we know a lot more that we can do. So it's going to come down here. It's going to go through this 0. It's going to go back up to this 0. It's going to go all the way up to 36. And then somehow, some way, it's going to come back down and go through 2, and then back up through 3, and then go up forever and ever to the right. So it's kind of look a little bit like a W shape in this way. All right. Any questions on this graph here? Okay. So in our next one, I'm gonna let you start from the get-go, from the very beginning. The factoring technique here is a little bit different than the one we've done before. I'll give you a hint here to think about GCF and how you can use that. But see if you can take it from standard form and plot the best graph that you can. Okay, so with this one, it's a little bit different because we're going to think about GCF first. So what can we factor out of this entire function? Yeah, negative x. That's going to leave us with positive x squared, positive 5x, and positive 6. From there, we can actually factor the quadratic that's left over. So we can factor that into, let's see, what multiplies to give us 6, adds to give us 5. 3 and 2. So, I know we haven't seen this before, but when you have an x as one of the factors, you can think about it as x plus 0, if you want to. But this is a factor. It just so happens that the x-intercept that we get from that is just 0. Which makes sense, because if we think about our y-intercept from the very beginning, standard form, what's the d value up there? It's 0. So if our y-intercept is 0, it's also going to be an x-intercept. So it makes sense that that ended up being the case. All right, and then from here, we have a -3, and from here, we have a -2. So we have a degree 3 function. It's a cubic, but it's a negative cubic, so that means the end behavior is going to be up to the left and down to the right. We know that that's going to end up being the case. So let's go ahead and plot our zeros here. X-intercept of 0, -3, and -2. None of these have a multiplicity, so all of them are just going to go straight through at those points. So let's see here. It's going to start up here, it's going to come down through this 0, and then at some point it's going to turn around. We don't know exactly where, but it's going to go back up through this one, and it's going to come back down through this one, through the origin, and then it's going to go down from there. So again, this is a rough sketch. It's not a perfect graph, but we can use those key characteristics to at least graph a pretty good representation of what we have here by this function. All right. Up next, we have x cubed plus 2x squared minus 4x minus 8. So take a second and see if you can do that one. Okay, so on this one, we're going to jump right into it here. We're going to factor by grouping. Before we even do that, though, we could say the y-intercept here is -8. I'm going to plot that. But if we factor by grouping here, we're going to have x squared times x plus 2 minus, let's see, we'll take out a -4 here, times x plus 2. From there, we can factor out x plus 2 from the entire thing, leaving us with x squared minus 4. The interesting thing here is that this factors one step further. What does that factor to? This one here.
X minus 2x plus 2.
Yeah, x minus 2x plus 2. So we have x plus 2 times x minus 2 times x plus 2. Or we could rewrite that, since we have two factors of x plus 2, we could rewrite this, if we wanted to, as x plus 2 squared times x minus 2. So that is fully factored form. I mean, so is this, but just written differently. We know it's a degree 3, as we see from this, the beginning here. So it's a cubic. It's a positive cubic, so it's going to end up going down to the left and up to the right, because it's a positive odd degree. So thinking about the end behavior there. It's going to have zeros at positive 2 and at negative 2. You got to be careful though. What's different about this one? Yeah, it's going to have a multiplicity of 2, so it's going to bounce off of that point on the x-axis here. So multiplicity of 2. So just keep in mind it's going to bounce off of that one. So at negative 2 and at positive 2. Well, let's see how this makes sense, right? Like if we thought that it went straight through at negative 2, then something's wrong, right? Either our y-intercept should be up here somewhere, or we should have another 0 to get back down to it, right? Something's wrong, right? If we didn't catch that multiplicity there. So it's going to start down here to the left, and it's going to come up and bounce off of the x-axis here at negative 2. It's going to be treated kind of like a quadratic right there, and then it's going to come back down through negative 8. It may or may not be the relative minimum there. We don't know exactly. It could come down here and then back up. We don't know exactly what it looks like, but we do know it's going to come back up through positive 2 and go up from there. So it matches the end behavior we've talked about. It matches the bounce. It also matches the y-intercept. So all of that works together to form this graph. All right. So hopefully that gives you a good practice there and a good idea of how to take from standard form to factored form, so then we can graph it as we did back in Unit 1. Now that we have access to all these factoring methods, we can use those to help us graph these polynomials. All right, so in our next video, we're actually going to use factoring again to help us do something, but it's going to be a little bit different. We're going to use factoring to simplify fractions involving polynomials. So I hope you'll join us then.